So we're going to talk about how to differentiate inverse functions. We have our formula at the top. It says if f of g of x equals g of f of x. Basically, if this is true, that means that f and g are inverse functions. So this is basically saying f and g are inverses of each other. Inverses undo each other to free up that x. So if f and g are inverses, then this is our formula. G prime of x equals 1 over f prime of g of x. Below, we basically have the same thing. Here, f and f inverse are inverses of each other. And then we have a second version of the formula. It's the exact same formula. Note that here, our notation, they put f inverse, f, and then that -1 in parentheses, and then the prime, so this is the derivative of the inverse, equals 1 over f prime of the inverse of x. So you could write the formula either way. They mean the same thing. Let's do some examples. It says f and g are inverses such that f of 2 equals 8 and f prime of 2 equals 4. Find g prime of 8. We're going to go straight to that formula, g prime of 8, and I'm going to use this top formula. That equals 1 over f prime of g of 8. To solve this, I'm going to start by, we need to figure out what g of 8 equals. Now notice they told us f of 2 equals 8, f prime of 2 equals 4. So they did not give us g of 8. But if we know about inverses, we know that if f of 2 equals 8, I can switch the x and y values. That means g of 8 equals 2. That's a property of an inverse. If I have one ordered pair for f, I can switch the x and y, and that's automatically an ordered pair for g. So g of 8 equals 2. I'm going to plug that in. I have 1 over f prime of 2. So instead of g of 8, I have 2. Now I need f prime of 2, and they did give that to me. F prime of 2 equals 4. So I get 1/4. Let's do a second one. Number 2, they're saying r of k of x equals x, and k of which equals k of r of x. That's them telling us that r and k are inverses. And they gave us k of 4 equals -9, k prime of 4 equals -2/5. And we want r prime of -9. So I'm going to plug into the formula again, 1 over k prime of r of -9. So I need to start by figuring out r of -9. Same thing, notice they gave us k of 4 equals -9. That means r of -9 has to equal 4 because k and r are inverses of each other. So I get 1 over k prime of 4. Notice they gave us k prime of 4. That's -2/5. Simplify, we get -5/2. And that is my r of -9. They could also give you a question like this where you have to pull values from a table. So that's what we have below. It says values of a strictly monotonic function g of x and its derivative g prime of x are shown below. It's saying monotonic. Monotonic means that g of x is always increasing or it's always decreasing. And they're telling you that because that means that g of x is 1-to-1, which means that it has an inverse. Below, they're saying if h of x is the inverse of g of x, find these two values. So I want h prime of 2. I'm going to go directly to my formula, 1 over g prime of h of 2. Now your chart only has values of g, but we're going to do the same thing we did above. If I have an ordered pair for g, I can flip those, and that's an ordered pair for h. So I want h of 2. I want you to notice, here's a 2 right here. G of -1 equals 2. That means that h of 2 equals -1. So I'm going to plug -1 in for h of 2. My last step is I want g prime of -1. That's going to be this -1/3. So I get 1 over -1/3. Simplify that, and we get -3. We have one more. I want h prime of -3. I'm going to plug into my formula 1 over g prime of h of -3. I'm going to do the same thing I did before. Notice I have a -3 right here. That means that g of 4 equals -3, which means that h of -3 equals 4. So this is 1 over g prime of 4. G prime of 4 is right here, that's -5. So I get -1/5. And these are some examples of differentiating inverse functions. Thank you for watching.